So in this video, we're going to look at modeling with quadratic equations. So in example 1, we're told that the annual profit made by a company is modeled by this equation, where the profit is equal to 80 minus 5 lots of x minus 8 squared, where P is the profit in thousands of pounds, and X is the selling price in pounds of their product. For part A, we've been asked to explain why £12 is not a suitable selling price. So this £12 would be our X value. And if we substitute the £12 into our model, well, the profit will be equal to 80 minus 5 lots of 12 minus 8. And then this is squared. Well, the 12 minus 8 is 4. So the profit will be 80 minus 5 lots of 4 squared, which is 16. And 5 times 16 is 80. So the profit will be 0. So we can say then that a selling price of £12 would give 0 profit. And that's why it's not a suitable selling price. Okay, so for part B, given that the company made an annual profit of more than £40,000, find the least possible selling price for a membership. So we're told that the profit is in thousands of pounds for our model. So we'll say 80 minus 5 lots of x minus 8 all squared is going to be greater than 40. And now we need to solve this inequality. So if we move the 5 lots of x minus 8 squared to the right-hand side and the 40 to the left-hand side, then we get 40 must be greater than 5 lots of x minus 8 squared. We can divide both sides by 5, so 8 must be greater than x minus 8 squared, and then we'll expand out these brackets, and we'll make the inequality equal 0. So 0 must be greater than x squared minus the 16x plus the 64 minus the 8. All I've done is I've moved this 8 to the right-hand side. Okay, so if 0 is greater than this quadratic, then x squared minus 16x plus the 56 must be less than 0. And now we need to sketch this quadratic to find out where it is less than 0. So we have the quadratic, and it is less than 0 when the curve is below the x-axis. So we'll shade this in purple. What we want is the least possible selling price. So we need to find the roots at this point and at this point. So we need to solve this equation. So if we solve x squared minus 16x plus 56 equals 0, we can do this using the quadratic formula. We get x is equal to £5.17 and x is equal to £10.83. So we can mark each of these on our graph. This one will be at £5.17 and this solution will be at £10.38. So between these two values, this inequality will be less than 0. But what we want is the least possible selling price. So this will be the £5.17. So this will be our solution, okay? And then for part C, state the maximum possible annual profit according to the model. So if we look back at this model, the maximum possible profit is when we have the £80 take away 0. So we need this part of a quadratic to equal 0. Well, the x minus 8 all squared can never be less than 0 because it's a squared function. So when x equals 8, all of this will become 0. So we're left with the maximum profit when x equals £8 is £80,000. Okay?